Now, in this lesson, we're going to factor special products. The two main ones we're going to look at are perfect square trinomials and difference of two squares. The key word is squares or perfect squares. A number is a perfect square if it's the result of the square of another number. An example will help understand that. 4. 4 is a perfect square because it's the same as 2 squared. 25 is a perfect square because it's a square of 5 squared. 35 isn't because there isn't a whole number that such that when you square it, you get 35. You can think about it. 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. 35 isn't one. 144 is. It's a square of 12. In fact, you may actually want to list some of these and keep them as a reference. If you do it quickly, you got 4, 9, 16, 25, 36, 49, 64, 81, ... And where those come from? 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. You may want to make a list. Now we're going to be dealing with expressions. X plus 2 squared. Now we're going to find what expression gives us that if you multiply it out. No shortcuts here. I'm going to use full method. I'm going to rewrite it because the x1 and 2 means same thing times itself. Full it out. X times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. Combine your like terms in the middle. X squared plus 4x plus 4 is the answer. Now there's a pattern here. If you look at it, to go from here to here, square, double square. Square, double square. Take the x and you square it, you get x squared. Take the x times the 2, which is 2x, and double it, you get 4x. And then 2 squared is 4. Now, we're going to be going backwards. We're going to be factoring. And that's the pattern for these. Square, double square. It works for either ax squared plus 2ab plus b squared or ax squared minus 2ab plus b squared. But you know, I'm really not going to do it that way. I'm going to use the method, first and the last, because I think that the simpler you can make factoring, the better off you're going to be. The reason why I show this is if you're someone that likes to learn patterns, then by all means go ahead and use it. But I'm not going to. I see this right here. I don't see a GCF, but I do see squares. So I'm going to draw 2 sets of parentheses, and I'm going to do the first and the last. What times what is x squared? X and x. What times what is 4? 2 and 2. Everything is positive. Everything is positive. If I check it, I'm going to get that. X times, I've already checked it. I've already done it up here. X plus 2 times x plus 2 is x squared plus 4x plus 4. Another thing I have to do is I can rewrite it. Since I have the same thing times itself, that's x plus 2 squared. Now if you want to find the pattern or use the pattern, I'll use this next example to demonstrate that. 25 is a good number. 25 is same thing as 5 squared. But if I take that 5 and I double it, I'm going to get 10. So it does follow this pattern. Square, double, square. What that means is, I know it's going to factor as an x, and then a 5, and then a square. The only question left is it plus or is it minus? Well, anytime you see that minus sign right there, that's the sign you're going to use. Plus sign, sign I'm going to use. Now, if you want to use a pattern, you can. I'm not a big fan of patterns. I tend to make factoring a lot simpler. There's only 3 main things you need to know. GCF method, grouping method, and the FL method. That's the way I prefer to approach it. Let's do this one. No common factors, but I do see squares. 9 is a square of 3. 49 is a square of 7. That tells me everything I need to know. I'm going to go down here. Since I have squares, I'm drawing 2 sets of parentheses. And I'm thinking what times what is 9x squared. That's 3x. and 3x. What times what is 49? 7 and 7. Everything is positive, everything is positive. So, and if I were to check it, 3x times 3x is 9x squared. 3x times 7 is 21x. 7 times 3x is 21x. And 7 times 7 is 49. Combine the like terms. 21, 21 does give us the 42x in the middle that we're looking for. And that's how it factors. Now let's factor x squared plus 8x plus 64. This one is slightly different. Now, let's take a good look at it. 64 is the same thing as 8 squared. But if you take 8 plus 8, we don't get 8, we get 16. So it's not going to factor that way. In fact, 8 and 8 is the smallest we could try. Because if we try 1 and 64, because right now I'm thinking of factors of 64. 1 and 64 won't give us 8. 2 and 32 won't give us 8. 4 and 16 will not give us 8. And the only thing left to try once again is the 8 and 8. So if the 8 and 8 doesn't work, chances are it's not going to factor. Anytime that happens, prime. Now everything's going to factor. Keep that in mind. So with conclusion of difference or a perfect square trinomial, I recommend using the first and last method. Use the pattern if you feel comfortable with the first and last method, but I strongly recommend that. And now we're going to look at a difference of two squares. Let's see what happens if we follow this out. Let's take x times x is x squared, x times negative 2 is negative 2x, 2 times x is positive 2x, positive 2 times negative 2 is negative 4. Notice common terms cancel out. Plus 2 minus 2 gives us a 0, leaves x squared minus 4. The result is a difference. Difference means subtract two squares. X is being squared there, and 2 is being squared there. Now when we factor, we're going to go this way. But once again, if you want to use the pattern, you can. Otherwise, I recommend using the method. And these numbers are a big deal. Here we go. No GCF, but I see squares. I'm drawing two sets of parentheses. All I have was the first and the last. What times what is x squared? What times what is 16? What times what's a negative? Positive and negative. Doesn't matter which one comes first. Now the reason why the pattern here is actually a good thing to know is because it makes it a whole lot easier. This number right here tells you everything you need to know, and plus the sign. Difference of two squares. In order for it to factor as it does, these two numbers have to be the same. That's the only way that the middle terms, when you pull it out, that's the only way that these terms will cancel out if they're the same, except for the sign. So that's why it has to be a difference of two squares. But once again, if you don't like the pattern, just do the method. First and last. No GCF. Does have squares. So I'm going to draw two sets of parentheses. What times what is x squared? What times what's a negative 100? Check it if you like, but I know it's right. Now this one is interesting. Be careful with this one. Now, some people want to think no GCF and two squares. They want to think the answer is this because they see that 25 and they automatically think 5 and 5. And since that's a positive, that's going to be a positive. If you follow that out, you're going to get 5x and 5x in the middle, which doesn't cancel out. It gives you 10x. What that means is that doesn't factor. The only other possibility you could try to get a positive when you multiply are two negatives. But the thing is, it ends up being a negative 10x. The only way that if you have two terms and you're factoring and you're doing squares, this has to be a minus. Otherwise, it's not going to factor as a product of two binomials. Keep that in mind. Doesn't mean that it can't factor by the GCF method, because they very well could. And a quick example of that is something like this. 4x squared plus 16. Now in this one, you do see two squares, 4 and 16, but the plus sign won't let it factor. But it does have a GCF. And you divide by that 4, which is a GCF, and you get that, and that's as far as that will go. So some of the squares do not factor as a product of binomials, but one, sometimes you have GCFs. Always take out the GCF first, no matter what. Now let's go back to our difference of two square problems. 4 is the square of 2, 81 is the square of 9. Got that minus sign that I need. I'm ready to go. No GCF. Couple squares. What times what is 4x squared? What times what is 81? What times what's a negative? Positive and negative. 2x minus 9, 2x plus 9. This one, some people are getting the habit thinking that I gotta draw two sets of parentheses. No, this has a GCF. Always take out the GCF first, no matter what, which is 3. When you divide each by 3, you get x squared minus 1. Not done. 1's a perfect square. 1's a square of 1, which means that this part will factor two sets of parentheses. What times what is x squared? What times what's a negative 1? Don't forget to bring that 3 down. And that's how you factor difference of two squares and perfect square trinomials.